Okay, so up to this point, we've only been talking about equations. You solve for x and you get one answer, am I right? Right? X is equal to 2, or x equals 8, and minus 3, or something, right? Each equation has its own answer. But there are problems where there are not just one answer. There are problems where there are an infinite number of answers. But they start somewhere, there's some place where they begin, and then they don't ever end going in that direction. And those are called inequalities. And I know you guys, I'm assuming everybody has experienced these. But just to be safe, I'll just make sure I know where I can go. Hang on. Okay. So just to be safe, I'll just do these. So if that is less than, right? You guys all know that? And then this is less than or equal to, right? Whoops. Less than or equal to. Equal to. And this is greater than. And this is greater than or equal to. Greater than or equal to. Okay? So, examples of, can anybody think of an example of an inequality in real life? Tom?
Say like you gave yourself like 10 apples and you gave your friend like 2 apples.
Okay, so that would be an example of an inequality, right? That's not fair, it's not equal, right? But in terms of an actual equation, like let's talk about like driving age. Like how old do you have to be to drive in New Mexico?
15.
16. Well, 15.
I think it's actually 15 technically.
Yeah.
I think it's 15 and a half, I believe. It's something like that, 15.5. So in order to drive, I think you're saying that we'll make X be the required age, right? You must be 15.5. You agree with me? Unfortunately, the people that are 16 and 17 won't be able to drive anymore.
No.
Because the way that's written, only people that are 15.5 years old can drive. Right? Yes?
It's people greater than.
Oh, so people greater than 15.5. That means as soon as you become 15.5, you're not eligible yet.
No.
You have to be past that.
No.
Oh,
Greater than or equal to.
greater than or equal to. Oh, there we go. So that makes sense, right? So suddenly that explains our age limit. You can be equal to 15.5 years old, or you can be greater than, and you can still drive. But if you're less than that, it's not going to work. So that's an example of many hundreds and thousands of examples in real life where this kind of stuff is useful. Now, the question is, let's just try graphing this for a second. If you graph this, usually you graph this kind of thing on a like a number line, or just a one-dimensional line, because it's only one variable, so you only need one dimension. When you start to move into two variables, you need 2 dimensions, so you need a graph that's a coordinate plane, right? If you had 3 dimensions, 3 variables, you'd need to have a 3-dimensional graph. You've got it this way, and deep, right? Going that way. So, but we're going to, for now, we're going to work on this. So, if this was 0, and this was 15.5, I have to mark this graph in some way. Now there's 2 ways to do it. If I do a solid dot like this, just above the graph, that tells me that it starts at 15.5 and it includes 15.5. And now notice it says x has to be greater than 15.5, which is greater. Isn't this greater?
Yeah.
So I've got to put an arrow going this way. Now and so that's the way you graph it. It's really easy.
Our
Yes.
teacher told us when we were graphing them, we sort of like that like pointy thing on the thing. Like, what's it called, Bo? That pointy thing when it's like that.
The inequality sign?
No.
This thing? This.
Yeah, if you look at that side, it sort of tells you which way you have to go for the arrow.
Yeah, as long as your x is on the left side, right? If your x is on the left side of the inequality sign, notice the inequality is pointing to the right. That's the direction you're going to draw your thing. Now, if I could have written this backwards, I could have written 15.5 is less than or equal to x, right? That says the same thing, right? But technically, when I read these, I always read them starting from the x. So in this case, x is greater than because the bigger mouth is facing the x. The tiny, tiny point is facing the 15.5. So the greater mouth means the x is bigger, right? Right? But if I read this, I do not read it as 15.5 is less than or equal to, less than or equal to x. I read it backwards. I say x is greater than, even though that's a less than or equal to, right? You agree with me? That's less than or equal to, wherever I am. Yeah? Right? But I'm reading it backwards. X is greater than. The bigger mouth is facing the x. X is bigger than 15.5. Now, notice, when you write it this way, notice the direction that if you thought of this as an arrow, that would be pointing in the wrong direction. But because this x is on the left side, and you can think of this as like an arrow, and it shows you the direction that you're going to be moving on the graph, right? Does that make sense? See that? So it says you're going to go to the right. Go to the right. Bigger, right? Now, what if I had said this, though? Let's graph this one. Say x is less than 7. All right? Not less than or equal to, but x is less than 7. Okay, here's 0. Here is 7. What kind? Would I put a solid dot like that?
No.
Do you guys all know this? You do an open circle, right? And you go to the left because it's x is less than 7. Where is 7? Where are you less than 7? Well, 0 is less than 7, so I'm going to go in that direction. Pretty easy, right? Pretty straightforward. Okay, so that's not the hardest stuff. And actually, to be honest with you, none of this is that hard.
Will this be on the quiz?
No. But I'm just doing this now because when you finish the quiz, you can do the homework. You can work on the homework. Because some people will go fast on the quiz and some people won't. What? This is what the homework's going to be.
We have so much
Is that what you asked? All right. So now we've got to talk about solving inequalities. Inequalities. And I don't know yet how many people already know this, so I'm just going to do it. But if I gave you something like this, 2x is greater than x plus 9. All right. This is the rule. Solve them exactly like equations, with one exception. One exception. Does anybody know what that exception is? Silas, do you know it? You have an idea? Do you, Sachi?
I think it's like you can't really know what like x is because it's not equal to. It's
Well, you're always going to have your inequality sign, right? So you're right. It's not going to ever say x equals. It's always going to say x is greater than or equal to, less than or equal to, right? But
what I mean is like we don't know what x is.
yeah, but there are two things. Well, there's one exception. If, and this is the exception, if, and this is really, really important to understand, because you've got to be really focused and really awake when you're doing these. Because you have to ask yourself every time, am I doing this? If you divide, well, if you multiply or divide both sides by a negative number, negative number, comma, then the inequality sign switches. inequality sign switches. All right, so if it's pointing to the right, it then now points to the left. And we're going to do a few. And you'll see. It'll make sense in just a second. So this one, it's okay to add and subtract from both sides without switching the inequality signs. It's not okay to multiply and divide by a negative without switching the inequality signs. Okay, so how would I solve this? I have x's on both sides of the inequality sign. What would I do?
Would you add the x's together?
Yes, I want the x's on the
So
same
you do
side.
3x.
Well, I want them on the same
Oh.
side. Like this is like an equal sign, only it's now.
So it's
So I got to do the same thing. I got to subtract x from both sides,
Yeah.
right? I'm going to subtract x, and that gives me 1x, right? Is greater than 9. Oh, wow, that was easy, right? Pretty easy, straightforward. Now I got to graph it. X is greater than 9. Here's 0, here's 9. Greater than, it does not include the 9. It's only greater than, so it's an open circle. And I go wherever it's greater than 9, that way. Pretty easy, right? So that's our first one. Is it clear to you guys? Am I
Yeah.
throwing? I'm not. I saw a question mark in your.
What happened to the 2? I'm just
Ah, because this is 2 x's, 2 apples, and I just took away one of them. I only have one.
I get it
I
now.
only have one apple left, or 1 x left. See what I mean? Okay, so that's our first one. Can I erase this now that you have that in your notes?
Don't erase the problem.
But I can erase this, right?
Oh, dang it.
Okay. Okay, so let's try another one. Let me just grab my sheet and just see if I can make sure that I'm giving you tons of that are like what you'll see. Let's see. Well, let's do another. Okay, let's do this. Let's say negative 4x plus 6 is less than or equal to negative 10. Okay? What would I do? Pretend it's an equal sign for a second. Think of it as equal sign. What's the first thing you think of doing?
You subtract 6.
Yeah, you want the x's all by themselves, just like on an equal sign, right? Just on an equation. You want those by themselves. So let's get rid of the 6. Subtract 6. Subtract 6. Do I have to switch this thing?
No.
I'm only subtracting 6. When you subtract or add, you don't have to switch the inequality sign. It's totally fine. So I have negative 4x is now less than or equal to negative 16. Now what do I do? What would you do? Yeah, Gavin.
You could probably maybe divide. Yeah, divide.
Divide by what? By what? I didn't hear you. He's waiting to hear what everybody's saying. No. What were you saying? You're right. Whatever's in front of the x, right? Gavin, you know this. You're just scared to say it, but you know it. I know you know it. It's whatever's in front of the x is what you're dividing by. And in this case, it's negative, right? It's negative. So we're going to divide both sides by negative 4. And suddenly we just woke up, right? We just woke up. We're dividing by a negative number on both sides. Oh my gosh. The negatives cross out. The 4's cross out. I have x. What do I have to do now? Here.
Try and switch it.
I have to switch it. I've got to make, instead of less than or equal to, I've got to make it greater than or equal to. And then the negatives cross out, and I just have 4. Does that make sense?
Wait, I don't understand the switchy thing.
But why do you switch it? Like,
All right. Can I erase this one now? I'll show you why. Because I'll solve it without using dividing by a negative number, okay? Watch this. If I had negative 4x plus 6 is less than negative 10, and then I subtracted 6, and I had negative 4x is less than or equal to negative 16. All right? Watch this. Instead of multiplying and dividing, I'm just going to add 4x to this side. Okay? I'm going to add 4x to this side. Add 4x to this side. And I have what on this side? 0, right? 0 is less than or equal to negative 16 plus 4x. You guys agree with me? Right? I didn't do any dividing or multiplying. Right? Now I'm going to add 16 to this side. I'm going to add 16 to this side. And then I've got now 16 is less than or equal to 4x.
Okay, I get it now.
All right. Notice the 4x is greater than or equal to 16. If I divide by 4, I've got x is greater than or equal, whoops, greater than or equal to 4. You see what I mean? So if I flipped it, if I put the x on the left, I put the big mouth towards the x, big mouth towards the x, 4. See, if I hadn't switched this, when I divided by a negative, I would have had x is less than or equal to 4. But I know this one's right. See what I'm saying? You see what I mean? I know this is right because I didn't do any dividing by a negative number or multiplying. This one, because it's a shortcut in essence. By being able to, if you want to divide both sides or multiply both sides by a negative number, this sign has to flip. It's a shortcut. So that you don't have to do this. You don't have to subtract the 4x, add the 4x to both sides. Yes, Sachi. Okay.
So instead,
How is those different?
oh, because Sachi, look, okay, I thought the same thing at first.
Okay.
So look at the first one we did, number 2. It says that, okay, so we got down and we got negative 4x is less than or equal to negative 16, right? And then you divided them by negative 4. And on the other one, you added.
All I did is I added them, I moved the negative 4x, well, I added 4x to the other
instead of
side.
dividing.
And then how's the answer different?
The answer is not different.
It just takes a lot longer.
This is the same answer as this.
Oh, I thought you were saying that the second one.
No, but I'm saying if you didn't switch this, then this would be wrong. Do you see what I mean? Because I proved that this is right. I know this is right. But because we're dividing by a negative number, that's a shortcut. You would allow, see how much longer that took us to do that? It's much quicker to divide by a negative number. And so by dividing by a negative number, I have to flip this sign. So you have to always be aware of that and awake for that. I'm going to give you the quiz on Monday. Is that okay? I think that's going to be easier. All right. So, because I want to keep going, I just want to give you a few more examples so that you really know, so that you really understand how to do this. All right, 3. What if I gave you x over negative 3 is equal to 10? All right, here we go. Next one. X over negative 3 is equal to 10. All right, immediately, oh shoot, there's a fraction in this
You have to
dog.
multiply it
By the
by the denominator,
denominator, right. So easy. What's the denominator?
negative 3.
Negative 3. So I'm going to multiply this side by negative 3. I'm going to multiply this side by negative. Oh my God, I'm multiplying by a negative. Both sides. So suddenly, the negative 3's cross out, right? That just gives me x. Oh, not equal, sorry. Sorry, let's make it greater than or equal to. I apologize. Sorry. All right, greater than or equal to. All right, so now what do I have to do? I just multiplied by negative 3 on this side.
What's the sign?
This sign has to be flipped, so it's less than or equal to negative 30. Easy, right?
Yes.
It was easy. You just have to remember that little trick, and then it's easy. It's like no problem. Okay? Yes? Question? Oh yeah, we got to graph it. So, x is less than negative 30.
On the homework, do you want us
All
to
right,
graph it?
do not do this. Do not do this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 5, 6, 7, 8, 9, 30. Don't do that, okay? I don't care about that. All I care about is that you show me where 0 is and where negative 30 is. Should I put negative 30 over here? No, because negative 30 is below 0, right? So I just want to see a 0 and a negative 30. That's all I want to see. And then you say x is less than or equal to, solid or open?
Solid.
Solid, because it also includes that point, so it's got to be solid. It includes this point at negative 30, and x is less than that. Less is this way. We can just follow that direction of that arrow there in the inequality sign. Okay, 4. See if I can find one that's harder. All right, how about this? Negative 10x plus 2 is less than negative 4 times 2x minus 3. Something like that. Okay, so that looks a little harder.
Wait, Gary,
But you have to
I have a question for the number 3.
Yeah.
Do you have to graph it on the homework?
Yes, I'm asking you to graph them all. Yes. And it's so easy, it's so quick, right? It's not a problem. You won't have trouble with it. Number 4, distributive property, right? I gotta do that. So we've got negative 10x plus 2 is less than negative 8x. What is it? Negative, plus or minus 12?
plus.
Plus 12, good. Awesome. So what would I do? What's the first thing you guys would do?
Flip the sign,
Well, why? I haven't divided or multiplied anything by negative 1.
then you multiply the 4.
Well, but I only did, but see, that's already there, and I only did it to that side. I haven't done it to both sides.
Oh,
That's why that both is important. Does that make sense? That's a great question. Blake?
Add 8x to both.
Yeah, that's what I'd probably do. I'd add 8x to both sides. Add 8x.
wait, wouldn't you do it?
Well, just hang on, I could do it the other way. I could have added 10x. But I kind of like my x's on the left side, don't you? Right? Especially with inequalities, because that makes them easier to graph. So I'd almost rather deal with a negative x on the left side than have my positive x on the right side and then have to move it over, flip it. You see what I mean? If it were me, but it's up to you. You can do it any way you like. But I now have a negative 2x plus 2 is less than less than 12, right? Those crossed out. Is less than 12. And I'm going to now subtract 2, right? Subtract 2. I have negative 2x is less than 10. And now what do I do? Divide by negative 2? Negative 2 divided by negative 2. Okay, so I divided by a negative on both sides. X is now greater than, this sign flips, greater than negative 5. And I'm going to graph it. Here's 0. Here's negative 5. X is greater than, open or solid?
Open.
Open, because it doesn't include negative 5. It's only bigger than negative 5, right? See that? Make sense? And which direction do I shake? Where is it bigger than negative 5? 0 is bigger than negative 5. A million's bigger than negative 5. I had to go that way. Or just follow the direction of your inequality sign, as long as x is on the left. Right?
Wait, so the open circle means
The open circle, okay, let's just write that down. Open circle, let me just erase this. The open circle means this. It's the boundary point, if you think of it that way, boundary point where inequality begins, but does not include that point. Does that make sense? Where it begins, but does not include that point.
I meant a closed circle.
Okay, closed circle, because it's closed, there's no airspace, it shows it actually touches that point. Does that make sense? That's why it's closed, it touches the point.
Goes up to that.
Here, it's open because it doesn't touch the point. It just goes up to it, but it doesn't include it. This includes the point. It starts there, it's the same, it's a boundary point just like this, except that it includes that point. Does that make sense? Great question. And I think that's basically all you need. Well, let's do one more. I'm going to do one that's actually on the homework, so that you don't get mad at me. Okay? This is number 23 on the homework. Number 23 on the homework. It says negative 1/3 times 2x minus 3 is greater than negative 2. Somebody is singing. All right. So what would I do? What would I do? Yeah, Tom.
Well, for you have to distribute the properties, right?
You could, right? So that's a great question. You could, right? And that's what I've sort of been teaching up to this point. But notice the only thing on this side is negative 1/3 times this blob here. And this blob is a binomial, right? I could distribute it, but I'm going to then get a weird bunch of stuff, right? Now, the question is, could I get rid of just the negative 1/3 in one foul swoop? Silas, what would you do? How could you get rid of that? Say it again, say it again. Yeah, so, yeah, and in this case, let's make the denominator negative 3, right? Or multiply by its reciprocal, which is negative 3, right? Either way. So look, we're going to multiply this side by negative 3 and this side by negative 3, right? So suddenly I'm multiplying both sides by a negative. Look at this, negative 3 over 1, those cross out. The negative times negative becomes positive. I just got rid of that negative 1/3. Does that make sense, Tom?
Yes.
You see how we did that? You could have done your way, and then you would have multiplied everything by the denominator. It would have worked fine. It's just this one extra step. You see what I mean? This is just saving you a step. That now is all that mess is gone. No equations, no
Would
fractions.
you change the sign?
Well, yeah, we haven't gotten there yet.
Wait.
2x minus 3, right? And then this, since we multiplied both sides by a negative, we've got to flip it to point the other direction. And then negative times negative is positive. 2 times 3 is 6, so 6. Now it's pretty easy, right? In one move, we went from really quite nightmarish to really quite simple, right? One move.
Wait, I have a question.
Yes.
So, 2x minus 3, like back to the original problem. 2x minus 3, wouldn't you have to put, wouldn't you have to multiply that by minus 3? By negative 3?
No, because think about it. If I had 2 times 3 times 4, all I have to go is 2 times 3 is 6. 6 times 4 is 24, right? I don't have to do 2 times 3 is
Okay.
6, and then 2 times 4 is 8, and then 8 times 6, I don't have to do that. I don't have to multiply the 2 times both of these. These are just two factors on this side. Does that make sense? You only have to multiply times one thing. This blob in the parenthesis is one thing. And this is one thing. So I'm just going to multiply it times this one. Does that make sense? That's a great question. Thank you for asking. All right, so now I just add 3, and I've got 2x is less than 9. Divide by 2, x is less than 4.5. Here's my graph. Here's 0, here's 4.5, right? It's less than, it's an open circle, it does not include 4.5.
Wait, so you're not changing the sign?
I did. See, I
Okay.
changed it up here when I did the multiply. See what I mean? But here, I didn't do anything with negatives on both sides. And so now, it's less than that, so I just draw my line that way. Straightforward? You guys get it?
Yeah.
Makes sense? It's actually pretty easy once you get it. You just have to stay focused and aware. Oh my God, I'm multiplying both sides by a negative number. I'm dividing both sides by a negative number. So that's all you need to know. All right, so the quiz